Hello friends, welcome back. I am Rajneesh and this session is about PXE Server Setup. As the name suggests, PXE stands for Pre-Execution Environment. That is, it establishes or creates an environment before a machine has been installed with an operating system. So before it starts executing, it sets up an environment for that client, VM or physical machine. How it actually happens: we have a PXE server and we have a client machine, physical or virtual machine, and what actually we have to do is, as soon as the client machine boots up, it fetches and boots from the operating system which is present on a remote server. So logically, if we think about it, this is a workstation that is not having any CD, or you can say that even it, in case it doesn't have a hard disk, it can boot from the network. But as we are planning to install the operating system on it, so we have a hard disk on it, but we don't have ISO or CD on it. And secondly, how the booting is happening over the network. As soon as we switch on this virtual machine, it sends a DHCP request, DHCP discover message to the DHCP server, in reply of which DHCP sends it the IP address of the TFTP server, and the location of the file from where it has to boot. As the TFTP server and the file location are specified, this client fetches this file from the TFTP server and starts booting from that file. NFS server has also been set up so that the complete distro CentOS 6.3 is exported through it, and the client uses this OS or the distro which is exported by NFS to start booting from it. So let's have a look into the requirement that should be met. First thing is, we have to configure NFS to export the operating system that is required to be installed. So in the previous session we have already configured NFS to export slash media for the same. So this part is done. Coming on to the second part, which is TFTP server, we have to do it, and the objective is to provide an environment that is necessary for the client machine to start booting from. Configure which hosts are allowed to boot from the PXE configuration. For this we have to configure DHCP server, that we will do. Configure the DHCP server and DNS server. Yeah, so DNS server has already been configured. If we are talking about test VM machine, we had a session on DNS server in which we configured entries for test VM. So we'll be using test VM, and we'll be installing an operating system on test VM using the PXE server. DHCP server has already been configured, but there is a slight modification which will allow the client to boot from that particular file. We will do that. So boot the client and start installation. Okay, coming on to the lab. Okay, so here is the server. So first thing that will happen is, this is my test VM which is going to get itself installed through the PXE server. First thing that will happen is the DHCP server. Okay, let's configure the DHCP server. Sorry, DHCPD or slash etc DHCP dhcpd.conf, and here this is my test machine. In case I want to allow this complete network to boot from PXE, then I can make entries inside this section itself. But right now my objective is to boot only a single machine from the network. So for this I'll be adding a few parameters, which is allow booting and allow boot p. boot protocol. So this will be allowed for test machine. Secondly, to allow this test VM to boot from a file which is located on a remote server, we'll be needing two other parameters also: the TFTP server's IP address from which I get the file and the exact name of the file. So TFTP server can be specified by the argument next server 192.168.1.205, which is the IP address of my infra server, and file name pxelinux.0. This is the file that this client will start booting from. Okay, pxelinux.0. Now I just restart it. Okay, now as I specified, we need to have a TFTP server on it. So let's install TFTP server and enable it. It should be under xanad. So it says disable equal to yes, mark it as disable equal to no to get it enabled, and restart xanad. chkconfig xanad on. Okay, now we have added one more service, which is TFTP. So we need to add a firewall rule to allow our network to have access to TFTP server. So let's create the IP tables rule to allow it. Here's the input chain, and 7 says NFS. So just before NFS, I'll add a rule for PXE. -I input at line number 7. Before that, let me create a chain for PXE. I think I already created it. Let me increase the size of it. Yeah, I already created it. So if it's not created, you can just create it with IP tables -n PXE. So second part is in the input chain at line number 7, we send it to PXE. So now at line number 7, the rules corresponding to PXE will be evaluated, and after that NFS. So inside PXE, let me see the ports for it. Ports for TFTP server that can be seen in file etc services. So IP tables -I pxe -p protocol UDP -d port. It's UDP -d port. Here you can see it works as port 69. -j accept, and service IP tables save. So I allowed UDP port 69, which is corresponding to TFTP, to be opened to wait, I have opened it for public actually. If you want, you can open it only for your network, which is 192.168.1.0. Let me modify it for the same. IP tables -f pxe, and now from source 192.168.1.0/24, allow it. Here we can see that it's allowing from a particular source 1.0 to UDP port 69. Now just save it. Okay, so TFTP server has been configured. initrd.d/TFTP. One more important thing that we have to look into is the document root or the root for TFTP server, which is var lib tftp boot. Okay, let's move to this folder. I'll show you one more thing. We exported a file which is file name pxelinux.0. So this file should be present inside the folder var lib tftp boot because it's acting as a root for TFTP server. Okay, let me see where it is. Actually, this file is provided by a package which is syslinux. So this package is already installed. In case this is not installed, and in your case I expect it not to be installed, so to install it, just type the command yum install syslinux, because this is the package that will be providing you the file pxelinux.0 -qa syslinux grep pxelinux.0. So here we can see that the file was provided by syslinux and is located at user share syslinux pxelinux.0. We just copy it to var lib tftp boot. Okay, now our DHCP server is set up to provide the IP address to test VM. It will provide the file pxelinux.0. So let's try to boot and let's see what is the thing that we are still missing. We'll edit it and we'll say in the boot options, the next time virtual machine boots, force into BIOS mode. The reason why we want is we may have to configure the BIOS to tell the client machine to boot from network instead of hard disk. There's some delay. Okay, it's already configured to boot from network. Fine. If we see into the logs, its MAC address is this one. It coordinated with the DHCP server and it got the IP address 192.168.1.208, netmask, DHCP IP and the gateway. Fine. Here you can see that it started booting from pxelinux. Why? Because I specified allow booting and allowed boot p, and second the TFTP server or the next server and this file. So till now you can see that it started booting from pxelinux.0. It tried to find out a file corresponding to its MAC address to boot from but was not able to find. And finally it said unable to locate configuration file. It means Moving on to var lib tftp boot. Here you can see that there is one file which is pxelinux.0 and client started booting from it. Okay, if I am not very much aware of how actually it works, I'll have a look into the configuration or the manual for it. rpm -ql sys linux, and let's have a look into the file which is pxe linux. So here you can see in user share doc there is a file which will display or explain how it works. You may go through this file because it'll explain you very clearly what actually is happening. So what we are missing is if a client starts booting from, it gets pxelinux.0 from TFTP's root folder which it has already received. After that it tries to fetch out a file from pxelinux.cfg which should be present in document root. I created this folder. Inside this folder it will try to fetch out the file name corresponding to its MAC address. In case it's present, this will be used to boot that particular VM from. Otherwise, it's the IP address which is converted into hex format, and after that it reduces the network size and it reduces the bits, and every time it reduces the bits and it moves towards the larger network for this IP address. And finally, in case you are not able to find the file, it will try to boot from default, which should be present inside pxelinux.cfg inside the TFTP server. So let's create a file default inside it. Okay, so this file will display how and where to boot from. First thing that we'll be needing is, okay, menu will come later. Let's understand the menu structure for it. Menu.txt, in the document you can see it. Let's copy any label from it. Here it is, label. Let's give it a name, CentOS 63. Menu label. This will provide us a shortcut, the caret sign. CentOS 6.3 kernel, the location of kernel. Let me create one more folder. And move to document root of or the root of TFTP server. Create a folder inside it, CentOS 63, and place initrd and vmlinuz for CentOS 63 inside it. Where will we be finding it? In media, isolinux, initrd.img. Let's copy it here, and vmlinuz, copy it over here. Now in the folder varlib tftp CentOS 63 we have these folders. Kernel will be CentOS 63 / vmlinuz, because till CentOS 63 you will find till TFTP boot you will find it to be working already as a TFTP route. Append initrd equal to CentOS 63 slash initrd.img, and let's create one more label CentOS. Let's create a label for local boot, or make it hard disk. Menu label boot from hard disk, and local boot is the option that you can set, and this is the hex value that you need to remember. So these are the most important two things that you may have to remind of. The other thing is, for menu you have to load the module corresponding to it. In case you want the UI to be visible, you have to use UI menu.c32. Now menu.c32 is not right now present in the TFTP route. You'll have to copy it, and you'll find it in user share TFTP, user share syslinux. So let's move to the folder TFTP boot and copy the file user share syslinux menu.c32 to this location. Okay, so menu is available and you have specified the two variables inside it. So you need to set the timeout, or you need to set out the default. Oh, sorry. So let me see for timeout. Menu timeout is, for example, this is 2 seconds, 1/10 of a second, and you need to specify the default for it also, the default operating system that it has to boot. Menu default indicates that this entry should be the default for this particular submenu. Okay, default, yeah, default, and then the label. So default we have to set to hard disk, so that in case the machine boots from the network, then also by default the operating system will not be installed on it and it will boot from the hard disk. Now I save it and quit. Now let me try to reboot this machine. Why is it getting delayed? Okay, so here you can see the menu and the default is hard disk. As you can see, I just click on it and now you can see that C is highlighted and H is highlighted. So if I just press C, I'll move to CentOS. H is hard disk. You can select any of the options and can start booting from it. Let me select CentOS 63 and just press enter. Now what will happen is it's booting from the network using the PXE server that has been installed on infra server. Did we save IP tables? If not, we should save. Did we switch on TFTP server? Or TFTP server is managed by initrd. Let's switch it on. Select language, keyboard, and now it's the NFS directory on which the installation media is present. Enable IPv4, IPv6 is not yet configured, so disable it. Click on OK. NFS server name or IP address. So it's 192.168.1.205 and CentOS is present inside. Media folder, mount options, you can leave them blank and just click on OK. Now you say Anaconda, it has started booting from it. Welcome to CentOS. Now as I already installed it, it'll ask me for whether we want to reinstall or we want to use this one. So let's reinstall it. System clock set to UTC. Let me set the time zone as UTC. Here it is. Passwords for the ease, I set it Red Hat, but this should never be used. Replace the entire operating system, click on OK. Write changes to disk. Now you can see that it has started installing the operating system from this PXE server. There is one more thing that we can do is we can create a kickstart file inside this PXE server so that every time it boots it is not going to ask me any details including the timestamp or anything else. So let me show you. Edit setting and we come to CD. Here you can see that CD is not mounted, so it's all booting from the PXE server. In the meantime, if you want me to recall the things, the two most important files that you need to know about is user share docs/linux menu.txt and pxelinux.txt. These are the two files that consist of the information that you will be requiring to set up the PXE server. Here it's about to get completed. I just wanted to show you after the machine has been rebooted, it should have the operating system installed with the basic packages. So this is the last package that it's installing. We had some manual intervention regarding the selection of time zone, keyboard type. You could avoid that by creating a kickstart package that we'll understand in next session. So it's installing the bootloader, and here to reboot just press enter. Now it has installed the operating system. It should have named this Linux VM, and right now you can see that it again booted from the network using PXE server. But we have two options, either to boot from the hard disk. This time we'll boot from the hard disk. Just press enter. So here it displays booting from hard disk, and here is the option. Root and Red Hat. Here you can see that how did it receive the host name and was able to configure it. The reason was we already had DNS server configured. So nslookup DNS utils is not yet installed. Here you can see that there are the repositories corresponding to CentOS. So in the next session I'll explain you to how to automate it so that even the repository that we want should be configured on it. For example, for our scenario, mv mkdir disabled and mv CentOS star to disabled, labs.repo. This is the repository. vim is not there now, so let's name it labs. Base URL equal to nfs colon slash slash 192.168 1.205 colon slash media check equal to 1, enabled equal to 1, yum repo list. Man yum. Okay, I have some mistake in base URL. I created it on slash etc httpd conf where www html conf httpd.conf, and at the bottom I should be able slash CentOS 63. So one approach is http 192.168.1. or let's name it by infra slash CentOS 63. CentOS 63 and yum repo list, and here you can see that it is working fine. So in the next session we shall understand how to automate that. Even the hostname entry, hostname was already there because of the presence of DNS server. Even in case you want the selected packages to be installed, that could even be done through Kickstart. So that's all for this session. We shall understand the details of other details of the PXE in the next sessions. Thanks for viewing the video. Have a good day.